We're going to define what a sequence is, and that definition is basically just a list of numbers that have a pattern. So a list of numbers that have a pattern would be considered to be a sequence. Okay, some mathematical pattern. So for example, 2, 4, 6, 8, 10 is a sequence of numbers. Okay, so you keep going up by 2, that is the pattern, starting from 2. This is also a sequence of numbers. 1, 3, 5, 7, 9, 11. Listing the odd numbers greater than 0. Okay, so this again is up by 2, but starting from 1 this time. And this is a different sequence of numbers with a different type of pattern. It's not adding anymore. Okay, so 1, 2, 4, 8, 16, and 32, that is multiplying. So you take the previous number, the first number, multiply it by 2, and then you take 2 multiplied by 2, you get 4. 4 multiplied by 2, you get 8. Okay, so that is the pattern with this sequence. And these are all sequences. Now the most natural sequence is this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the natural numbers, and we're going to relate all sequences and series to that sequence. Okay? Okay, the numbers in a sequence are called terms. So if I want to talk about the first term, well, in these sequences, it's 2, 1, 1, 1. The third term, well, you go third term in, so 6, 5, 4, 3. Okay, it would be the third term. So those are the terms in a sequence. And we're going to call term 1 T subscript 1. Term 2 is T subscript 2, and so forth, so that term n, so any term is going to be T subscript n. So T20 would be term 20, and so on. Okay. Now, the formula for the sequence is going to be called Tn as well. Okay. So that tells you how to calculate the nth term of a sequence, this formula that you get. So for example, here is a formula for Tn. 3n plus 1. Okay, so 3n plus 1 is the formula for that term. So if I want to calculate any term in this sequence, I have to know what n is. So if I want to calculate term 1, well then T1 would be 3 times 1, which is 3, plus 1, and that makes 4. T2, so T subscript 2, would be 3 times 2, which is 6, plus 1, which is 7. And whatever the n is, you put in here, and you get the value of that Tn. Okay, so n is the input for this function. Tn is the output. Okay, so if you want to find out what t is when n is 5, you'd find T5, which means T5 is the output, where 5 is the input you put in here to calculate. And here is a table of values that you get for this sequence. Okay, so if you want to check this out, so if you had 5, 3 times 5 is 15, plus 1 is 16. Okay, so this is a table of values basically written horizontally. So here's the n, the input. You know, we're often used to that being the x, and Tn, which is the output, we're often used to that being the y. But this is a discrete function. So discrete function means that we only have whole numbers as the input, or the term numbers. So you don't have any points between n equals 1 and n equals 2. And if you had to plot this graph of this, it would just look like a bunch of dots that lied in a line. Okay, so if you look at this also, if that was y equals 3x plus 1, that should remind you of a sequence or of a function that you're used to from grade 9. Y equals 3x plus 1 is a line. If that was an x, then 3 would be the slope, and 1 would be the y-intercept. Right? Y equals mx plus b. So there's m, there's b. And m is the rate of change. M is the change from the change in y values as x changes by 1. Okay, so 3 is the difference, we're going to call that here. Now, if I wrote this in a different way, like this, then basically, in this one here, if n equals 0, t0 equals 1. Well, we don't talk about the 0th term of a sequence. We talk about the first term of a sequence. If we talk about the 0th term, well, it doesn't really make sense. So the first term, second term, and so on makes more sense. So there's going to be a general form that I'll show you. And in this one, when n equals 0, tn equals 1. But in this one, when n equals 1, it makes this piece equal to 0. So when n equals 1, 0 times 3 is 0, and t1 equals 4, which happens to be the first term of this sequence. So the sequence is 4, 7, 10, 13, 16. Starts at 4, keeps going up by 3, which makes sense. So this is how you go up by 3 here. And when it's written in this form, instead of n, it's n minus 1. This tells you what the first value of the sequence is, t1. Okay, hopefully you can see that. If you had to calculate t8, it would be 25. Okay, so let's look at now what an arithmetic sequence is. Okay, so how is an arithmetic sequence defined? Well, it's just defined as a linear relation. Okay, so it's a linear sequence, means the points go up as a dot. So if you had to graph something like this, there's the Tn axis, there's the n, sorry, I just put an X there, the n axis, and you wouldn't have this. Okay, you wouldn't have any negative numbers. In fact, you wouldn't even have 0. So you wouldn't even see the Tn axis. You would see it starting from 1. Okay, so that would be the beginning of your graph for an arithmetic sequence, or any sequence. Okay, and the first term is going to be a. So say that's a on the graph. So that would be your first term. And d is a common difference. So if it keeps going up by d, then your next point, so there's 1, there's 2, there's 3, there's 4, there's 5, okay? So the next point on it would be at 2, and you maybe have it up here. Now, that value there is going to be a plus d. And then the next one would be up here. And next one up here, and so on. And those points would lie in a line for an arithmetic sequence. There are no points in between, though, because there is no term 1 1/2 or term 2 1/3. Okay, so an arithmetic sequence are points that lie on a line, but it doesn't create a line. Okay, so d in this formula is the common difference, or the slope. A is the first term of the sequence. Okay, it's t1. And you can tell that if you subbed in 1 in here, 1 minus 1 is 0. D times 0 is 0. 0 plus a is a. So if I plugged in 1 for n, I get t1 equal to a, no matter what d is. Okay. So some examples of this are, okay, so if you want to state the general term, which is the formula, so a general formula for this sequence, 17, 21, 25, and 29, and so on. Well, we notice that the common difference is 4. Okay, so it keeps going up by 4. So I'm going to put the 4 in front of the n minus 1. And the first term in this sequence is 17, so that's the A. Now you could simplify this so that you didn't have any brackets in it. So if you expanded and simplified, you'd end up with this, which simplifies to 4n plus 13. Okay. Now another sequence is this one. The difference here is this one goes down. So it starts at 35, it goes to 30, then 25, then 20, and so on. Keeps going down. So the first term in this sequence, the A, is 35, and the common difference is, well, it goes down 5. So it's going to be negative 5. And that's the equation we get. So from our definition up here, the common difference, D, is negative 5, and A, the first term, is 35. Okay, you can simplify that and you get negative 5n plus 40. Okay. Another sequence here, using some decimals, is this one, 17.2, 17, 16.8, 16.6. That one also goes down. It goes down by 0.2, and the first term is 17.2, so you'd fill it in like this. And then you can simplify this one by multiplying it out, and you get negative 0.2n plus 17.4. Okay. Now, another example. Here's one where you're given the terms and you have to come up with the formula for the sequence, but you're not given consecutive terms. So consecutive means one right after the other. So in this one, we're given T5, which is 357, and T8, which is 393. You're not given T6 and T7. So you know what the fifth term is and the eighth term is. And you know that it's arithmetic. If you know that, you can figure out the equation of this sequence. Okay? So the common difference, as I've said earlier, is like the slope. The formula for slope, well, m equals y2 minus y1 over x2 minus x1. Okay, so you can find the slope that way. You have 2 points here. This point here is equivalent to a point 5, 357, and this one here is equivalent to 8, 393. Okay, now you can do it this way, or you can also think of it as, well, this is a jump from 5 to 6, 6 to 7, and 7 to 8. So it's 3 common differences from 357 to 393. So if you calculate the difference between these two and divide by 3, that gives you the common difference because it's 3 jumps. Okay? Which is basically the same as this statement here. So common difference, y2 minus y1, x2 minus x1. Okay, it's the same idea here. The difference in the two y values, or the two t values, term values, and divide it by 3 because it's 3 jumps. Okay, and you get 12. So the common difference is 12. So now you've got this much. You've got Tn equals 12 times n minus 1 plus a. Got the common difference, but you don't have a. So how do we do that? Well, we can take any of the points that we've been given, the terms that we've given, and sub it in to find a. So for example, T5 equals 357. So you can take the 5, sub it in for n, and the 357, sub it in for Tn. And then all you have left to find is the a. Okay, so this is very similar to how we would do equations of lines, getting the equation of the line from a point and a slope. Okay, so T57, just show you here. So we're subbing in this into here, so 357 is there. 12 times 5 minus 1, because n is 5, plus a. And you keep working it down, and you'll end up with a equal to 309. And now we've got Tn equal to 12n plus 297 is the equation